Example 1. In one area of the Bay of Fundy, the tides caused the water to rise to 6 meters above average sea level and to drop to 6 meters below average sea level. One cycle is completed every 12 hours. Assume that changes in the depth of the water over time can be modeled by a sine function. Okay, so we're going to focus on sine. If the water is at average sea level at midnight and the tide is coming in, draw a graph to show how the depth of the water changes over the next 24 hours. Assume that low tide, the depth of the water is 2 meters. So when we draw graphs, for application graphs, do not use the method of fitting the axis to the curve. Okay, we're going to basically do a sketch, and we're going to try to graph as normally as possible without too much detail. We would just want to kind of get it just a nice sketch. It doesn't have to be, certain points should be quite clear, but it doesn't have to be perfect. So we want to show the depth of water and how it changes over 24 hours. So let's just look at this. Okay. All right. So we'll call this depth of water, depth with respect to time, right? D at any time. And this is going to be time. And it will be, they give us the period in hours, so we'll call this hours. Okay, now they're saying the water's at average level at midnight. Okay, fine, and the tide is coming in. They say low tide, so the minimum value is at 2. Just a little grid line to help us out. Now, it goes 6 meters below, just the way they describe it, below average sea level. So to get to average sea level, it must, if it started at low tide, which it doesn't, but if it's down here, it's going to, how many, what's the distance between here and here? Sorry? 6. So that makes 2 plus 6 equals 8, right? This is in meters. I guess we don't have to write meters all the way through. And then it's going to go 6 meters above the average sea level. So if we add 6 to that, we get 14, right? So it's going, average sea level is at 8. It's going up to 14, back down to 8, down. It follows a cyclical pattern or a sine function, going up and down, up and down. Okay? One cycle is completed every 12 hours. Okay, so they are telling you the period is 12 hours. Okay, that's what they're telling you. They're giving you information about the period, and if the period is 20, they want a graph over 24 hours, they're really asking us for 2 periods or 2 cycles. All right. Now, If the water is at average, so they're telling you the starting point, it's at average sea level, and this is at 12 midnight. I guess that would be AM, wouldn't it? Yes, it would. 12 midnight, or would that be PM? Yeah, yeah, you're right. It's AM because lunchtime is PM. Okay, very good. Sometimes you have to think about these things. Okay, so we're going to draw one cycle within 12 hours. So if this is 12 a.m., 1, 2, 3, 4, this would be 12 noon, right? 1, 2, 3, 4, and this would be back to 12 a.m. So this is according to our clock on the wall. Okay, so it starts there. It means it's going to go up there, back down, come down here. At 12 noon, it's completed one cycle, right? It's at average sea level at 8 o'clock, not at 8 meters, right? And the tide is coming in, so it rises, and then it comes down and falls and goes up. And they want another cycle, so that is going to be there, 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 and there. So that must make, let's do this, let's do time, if we do time in hours, this is a clock time. So this is 3 hours after midnight, 6 hours, 9 hours, 12 hours, 15 hours, 18 hours, 21 hours, 24 hours, right? So here's our time in hours. I'll just put it up a little bit higher. Let's write an equation for the graph. They want us to write the sine graph. All right. So the sine graph, the pattern for the sine graph is y equals a sine k x minus d plus c. Agree? Right? It looks like that. Yeah.
In the question, it says that if the water is at average level
At midnight. Sorry? Oh, this is part C. I'm still working on part A. Yeah, that's different from this, okay? Okay. This, if the average water's at sea level at 2, will be another equation, and it'll be a phase shift, okay? Okay, so and I think we have all the details now. We have our scale here, right, 2, 8, 14. We have this on the bottom. Okay, now we can come up with the graph where what we're going to do is we're going to call it depth at time t, right, equals a sine k t minus d plus c. And they want a sine graph. Was there a concern? Oh, you couldn't see. That was your concern. Okay, that's a valid concern. Where t is hours, spelling error, hours after midnight. Okay. Can anyone care to tell me what they think A is? What is A? Sorry? Huh? Huh? Yeah. Thank you. A equals 6. Okay. Now, we have to figure out K. K's going to be different. So we know our period is equal to 2 pi over K, right? Now, we know our period is 12. 12 hours equals 2 pi over K. So we're going to have to solve for K. 12, I'm going to, just for the sake of space, 12K equals 2 pi. K equals 2 pi over 12. K equals pi by 6. Okay? So, let's see what our equation looks so far. Do we have a phase shift? Is there a phase shift here? No, because typically when we did our sine function, it started there, went up and down. So you see it's starting at the origin. So there's no phase shift there, right? So D equals 0. And what does C equal? What's our equilibrium line? Yeah, 8. So our equation becomes D of T equals 6 sine pi by 6t, right? Pi by 6t plus 8. Can I explain anything better on that one? Let's look at part C. I'm going to do it in purple, okay? The only difference is now we have a phase shift. They're telling us if the water's at average sea level at 2 here, it means it's starting there, right? And then at 5, it would be the next key point, right? If it's starting here, we have a phase shift. So it just means that D is equal to 2. So what we have here is D of T equals 6 sine pi by 6 T minus 2, because it's going to the right, plus 8. And T again, T is hours after midnight. Now just a little extra for part B. Part B. What would be the cosine function? If we were to write a cosine function for part B, this is just an extra. Anyone want to give it a try? If the question asked for a cosine function, what would it be? Instead of sine, what would the cosine function? Any idea?
Do you change, like, do you change C?
You change the? Exactly. So the D in this case would be?
0?
D is 0.
Like, are you applying the shift?
We're applying it to the equation in part B. So on the sine function, there was no phase shift. So if we want to make a cosine function out of this, there's a phase shift, right? Because normally cosine starts, the max starts at the origin, right? But it's shifted how many hours to the right? 3, right? Right? So this would be d of t equals, where's my equation? 6 cos pi by 6 t minus 3 hours to the right, plus 8. Does that make sense? Okay. Oh, for this one? If it's a cosine function, yeah, just see where the max is. Normally the max is there. Pardon? Yes, it's still up there. Because cosine, if I put my vertical axis here instead of here, can you see everything remains the same? There's only a shift to the right. It's the only thing that's changed. So C is the same. The period is still, 15 minus 3 is 12 hours. That stayed the same. Our max is the same. Our min is the same. Just a different. Just instead of sine, we're using cosine. Okay, let's do a spring. Okay, let's try the next one. An object suspended from a spring. Okay, if you can just try to imagine this object that's suspended from this spring. All right, is oscillating up and down. The distance from the high point to the low point is 30. So they're telling you the difference between the max and the min is 30. So let's just see if we can start drawing a sketch of this. And the object takes 4 seconds to complete 5 cycles. So 5 cycles in 4 seconds. For the first few cycles, the distance from the mean position d of t centimeters with respect to time in seconds is modeled by a sine function. Sketch a graph for 2 cycles. Okay, let's see what we can do. So this will be distance with respect to time. They're telling you the variables to use, right? So they want the distance from the mean position. So let's see what that will be. So they're telling us max minus min equals 30. Can anyone tell us what A would be? 15, right? The amplitude is half the distance between the max and the min. So they're telling you it's going up 15 above some equilibrium line and down 15. So this is time And well, let's look at the time will be in seconds, right? We'll do a couple of cycles. Oh, they want 2 cycles. Okay. Okay. So they tell us 5 cycles in 4 seconds, right? So that means 1 cycle in 4 divided by 5 in 0.8 seconds. So special points occur every period divided by 4. Okay? So this is going to be 0.2, 0.4, 0.8, 1.0, 1.2, 1.4, 1.6. They just want 2 cycles. So we can lay it out as usual. Up. Uh-oh. Oh no, I think I did that right. Sorry? Oh, something went wrong, eh? I missed 0.6. Dag nabbit. Better start fresh. 1, 2, 3, 4, 5, 6, 7, 8. 0.2, 0.4, 0.6. I missed that. 0.8, 1.0. Okay, so we'll draw some. This is time in seconds, and this is d of t in centimeters, right? So there, there, there. Uh-oh. This is just a rough sketch. There we go. That's a little better. Okay. So again, let's take a look. So anyone want to tell me what A equals? 15, right? A is this, half the distance between the max and the min. So it's 30 divided by 2 is 15. So period is equal to 2 pi over k. 0.8 equals 2 pi over k. 0.8k equals 2 pi. K equals 2 pi over 0.8. Let's see, you can't have a decimal in a fraction. So this is going to be 20 pi over 8. I multiplied by 10 over 10, and that reduces to 5 pi by 2. Okay? So our k is this. We do not have a phase shift. This is 0, just the way we set it up. It's either 15 centimeters above. This might, yeah, above and below. It's hard to tell. I guess it would be, I guess if we goes up and down, it's hard to really position the spring. Is 15 down, or is, oh, the distance would be below? Yeah, the distance is greater to above the distance. Okay? Let's do one more example, a carnival Ferris wheel example, and then a carnival Ferris wheel has a radius of 7. And it makes one complete revolution every 16 seconds, so that's our period. The bottom of the wheel is 1.5 meters above the ground. Okay. So the bottom of the Ferris wheel between the ground and the bottom of the wheel is 1.5 meters. So when it's at this height would be 8.5, right? And then this height would be 8.5 plus 7. That would be 15.5 as the wheel goes up. Assuming a person gets on the Ferris wheel at its lowest point, so it's going to start at the lowest point. Okay, we'll do A part here. Draw a graph to show how the person's height above ground varies with time for 3 revolutions, starting when they get on at the lowest point. So again, do not use method of fitting axis to curve. We're not doing that. It's a real life situation, so fitting axis to curve. So the person gets on at, this is the height with respect to time, at 1.5 meters. So it goes up, the radius is 7, so the equilibrium line would be 8.5. Another 7, the high point would be, maximum height is 15.5. Perhaps I can fix this a little bit, so So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. This is going to be time in 1 complete revolution every 16 seconds. So time in seconds. So special points occur every 16 divided by 4. So this is going to be 4, 8, 12, 16, 20, 24, 28. I don't want to miss any this time. 16, 20, 24, 28, 32, 36, 40, 44, 48. They start at the low point. It starts there and it goes up. Max at 8 seconds after a person gets on, then back down to 8.5, then 1.5. At 24, it should be at a max again. And then at a low. Uh-oh, something went wrong. Okay, at 16 a low point. At 40 it should be a low point. So 20, 24, 28, 32. Yeah, 32 a low point. Note we're good. 36, 40 a max. Good. 44, 48. Sometimes extra grid lines are helpful, aren't they? So they wanted 3 cycles. Let's find the equation for this graph. We'll do one for sine and one for, they're talking about height, so we want to use h of t, not depth. H of t. Okay, find an equation. Alrighty. If we could deal with it as a sine function, we could deal with it as a cosine function. They don't seem to say, so we're going to do both. So our period equals 2 pi over k. We're just going to calculate k. So our period is 16 seconds equals 2 pi over k. 16k equals 2 pi. K equals 2 pi over 16 equals pi by 8. We know half the distance between the max and min is 7, or the radius of the Ferris wheel. So A equals 7. Actually, it would be it depends on our phase shift. Okay, if it's phase shift 4 to the right, so D equals 4 and C equals 8.5. So we're ready to fill it in. H of t equals 7 sine pi by 8 t. Normally sine starts there, but it's over 4 seconds to the right, so it's minus 4 plus 8.5. Now if we write this as a cosine function, if it's a cosine function, the max usually starts there, but it's just a negative a, right? With no phase shift. How many equations do you think we have? How many equations are possible for these functions? There's an infinite number. I could write another cosine function. For example, if I said the phase shift was 8, then this would be positive cos. Right? You could write an infinite number of equations for this. Now what happens if a wheel completes one revolution every 20 seconds? We actually get a, in part, how will the graph change if the Ferris wheel turns more slowly? What do you think is happening? Do we have a horizontal stretch or a compression? Yeah, it's a horizontal stretch if it's more slowly. So let's look at part B. We'll just part D, sorry. We'll just graph this again. So if the period is 20 seconds, 20 divided by 4 is 5. The size of the wheel isn't changing, just the speed of the wheel. So this is going to be, the height is h of t in meters. That doesn't change. Again, assuming a person starts at the low point. I mean, it's not like they can fly to the high point, right? There we go. At 50 we have a max. 55 down again. All right. Okay. So we could draw a sine function. Notice there's a phase shift here of 5 seconds. Period is 20, so period equals 2 pi over k. 20k equals 2 pi. K equals 2 pi over 20 equals pi by 10. So h of t equals 7 sine pi by 10 t minus 5 plus 8.5. So why don't we wrap that one up for today. You can try examples 4, 5, and 6 and any homework you have there.